For training our model, we are going to use a synthetic dataset that I have generated, and the file is also present. I'm not going to code it. You can get it from the GitHub of this code repository. So it has 12 columns, and it takes the smartphone features, and it returns what is the probability that this exact specification will get returned. So for example, if given brand condition, is it open box, new, refurbished, RAM, storage, carrier, discount, rating, or number of days since it was first purchased. Based on that, we tell whether it is the probability of it getting returned or not. So this data set has about 5,000 data points, very small data set, and it has about 17% data which has a high return rate. So let's quickly learn how can we write code with MLflow. So first thing first, we're going to install the dependency, which is uv add MLflow, and we also need the scikit-learn because we are going to use the simple random forest. And let's also install pandas and numpy, matplotlib to visualize the performance of the model, seaborn, let's install it as well, plotly, Jupyter IP kernel. Kernel. Let's give them a bit. It's installing all the required dependencies. Meanwhile, let's create the model. I have created a separate folder for the first episode. Let's make it train baseline because this is going to be our first model, and let's wait for it to get installed. And there we go, our model has been installed. Let's spin up the MLflow UI, UI. So this will start the MLflow UI, and this is how your MLflow UI will look like. There's no experiment right now, no model. This is clean slate. First time we are adding the MLflow. Now let's do import the dependencies. Let's import matplotlib .pyplot as plt from sklearn .compose import column transformer from sklearn .ensemble. Let's import random forest classifier, and from sklearn matrices, import accuracy score, F1 score, ROC AUC score, confusion matrix. From sklearn dot model selection, import train test split. From sklearn dot pipeline, import, let's import pipeline. From sklearn dot preprocessing, import one hot encoder, standard scaler, and from MLflow dot models, import infer signature. So now let's define the directories from let's also import MLflow. And we also need OS, import pathlib. From path, import path, and let's also import MLflow.sklearn, and we have to import numpy as numpy, import pandas as pd, and I think we are good. Let's define the paths. Let's define the root of this project as path dunder file. Let's make it parent. This is going to be really helpful because I believe you guys are running this code on Windows, Linux, anywhere. It is going to work. So what I am doing is I am telling it from root in that same folder you're going to find the smartphone, SMART PHONE .csv, and now let's define artifacts. Let's also save them in the artifact folder. Because the ML processes will generate some artifacts, and let's also make right away once this code execute. Let's make the directory and exist is equals to true. If this directory already exists, then we are going to skip it. Now let's do the MLflow setup. So let's do one thing. Let's MLflow set experiment. Let's make it as model baseline, or let's do, since we are going to refer multiple episode, So let's make it episode 1 baseline. It is going to helpful in because we are going to use the same model in the coming up series. So let's load the data. So df is equals to pt.read_csv, and we can pass data, and then we can split. Df.drop, let's drop the last column. Return, and the label is df returned as type integer. These are our features, this is our target. Now let's bring the numerical column separately. Select t types, include numpy dot number dot columns to list. So this way we will be automatically getting all of the numerical column name. And then let's get the categorical columns. Select t types, exclude. Again, if we exclude the numpy dot numbers, then this way we'll only get back the columns to list. So now it is going to help us in identifying the numerical and categorical column. You don't have to hard code anything. We'll try as much as possible to prevent hard coding. Let's do preprocessing. Preprocess column transformer. Now let's transformers. Let's build first the numerical transformer. Numerical. Let's do standard scalar, and we can do with mean is false, and let's pass all the numerical columns. So next transformation we'll do for categorical is they will be of one hot encoded, and we can say handle unknown as ignore, because since I have prepared this dataset and I have made sure that there is no unknown value, and we can pass the categorical column in this. Let's try to run see if any error that comes up. Episode 1 train baseline. Hopefully it will work. So meanwhile, let's build our model. Alright, there is an error. Smartphone returns. Maybe I have written a wrong name. So let's do it again. Yeah, so there's no error. We can continue building the model. So let's model in hyperparameter. So let's define the number of estimators. So let's do integer os dot get, or we can, usually these things are passed as a environment variable, but for now let's make it 200 max depth. Or let's do one thing. I'll do the code that goes in the production. So os dot get env rf and estimators, and if it is able to find it, otherwise we'll give a default value of 200. So that's how, because we want to make it configurable, that's the idea. Integer os, there are other ways as well, like you can pass it as the argument get env random forest max depth. Let's take it 12 if it is not provided, and let's give random state. Now let's define the model as random forest classifier. Number of estimator is number of estimators. Max depth is going to be max depth. Random state is going to be random state, and let's give number of jobs as, let's take it -1, and we can define the class waste as balanced. Now let's define the classifier as pipeline. Its steps are, first the preprocessing. We'll use the preprocess that we have defined here. Yeah, and after that it goes into the rf random forest. Let's pass our model. So this is an array. Perfect. Now let's call our train test split. So previously we have splitted the features and target variable. Now we are splitting the data. Xtrain by xtest. Train test split x comma y. Let's give the test size as 0.2 and random state as random state, and stratify y. We want to do the stratified sampling. Now this is the traditional machine learning writing way. Apart from that, we just had done an MLflow experiment setup. Now we are going to use with context for MLflow dot start run, and let's give the run name as baseline random forest, and inside that we are going to logs the MLflow parameters. And MLflow dot log param an estimator is an estimator, and max depth. So that way we will have the track, like for that this experiment, these are the hyperparameter that were used. So now let's run our classifier fit x train and y train, and then after that we'll do the eval. So let's get the predicted PRED CLF dot predict y test, sorry, x text, and let's also get the probability. As for now it's none. Let's do try and catch. So y probability CLF predict probability x test everything except exception. For now let's pass it. So now we'll have the probability, and that will be helpful in calculating the ROC AUC. So now let's get the accuracy score. Let's give y test and y predicted, and let's calculate the F1 score. y test, y predicted. So MLflow dot log metrics. This is a metric. Earlier we logged the parameter. Accuracy is and MLflow dot log matrix f1 is float of 1. Now if y probability is not none, then we can calculate the AUC, ROC, AUC score, y test, comma, y probability. MLflow log metric C float UC. Now let's draw the ROC curve. So let's import from sklearn dot matrices, import ROC curve display, precision recall display, and we can as plt dot subplot fig we can define the figure size as 5,4, and let's get the figure and access. Figure ROC, figure access ROC. And then ROC curve display from predictions y test, y probability, and access is access ROC. So we can give path. We can give the path as artifact. After that it will take ROC curve dot png. Now figure ROC dot tight layout. Dot save fig ROC path, and let's give the DPI of 160, and then we can plt.close the figure, ROC, and we can log the artifact, the MLflow log artifact as str of ROC path. And that's how you save the model performance. Now let's do one more thing, and let's save like artifacts. Let's give the information of class balance. Y dot value count, normalize true, rename access to class, reset its index, and let's give the name as PCT. Class balance path is artifacts / class .csv to CSV class balance path index, let's make it false. Now MLflow log artifact, we can give the name str of class balance path. And one more thing is the confusion matrix. Confusion matrix we can calculate as CM as confusion matrix, and we can pass y test comma y predicted values, plt.subplot let's give the dimension of 4 cross 4, then axcm im show and then we can put cm cmap, let's give it blues, set x label predicted values axcm dot we can give y label as actual, and now we can enumerate for I comma j comma v in np dot nd enumeration cm, so axcm dot text give the HA as center. These are the just formatting, and VA also as center. And we'll also need to give the color bar so that it's visible then cm path. You can define artifacts / png figure cm same thing, figure cm dot save fig. Then we can close the plot. Once that is done, we can log the artifact and str dot cm path. Finally, let's log the model. So let's infer the signature. Extreme dot head. Let's log 5 examples of input. refer signature will pass the input examples clf.predict examples flow.sklearn.log model clf name, let's give it model, signature is signature, and then input example. Let's also add a print statement. Accuracy is this, and f1 is, hopefully this is going to run. So there is error at subplot. Alright, let me define this way. Fig hopefully this is the last error. So clf name signature it's log model, not load. Let's see. Yeah, so model is trained, accuracy is 0.81, and this is the f1 score. Let's see our MLflow UI. Look, this is the experiment that got saved, some failed runs, and the final one, which is the success run. It is giving the information and all artifacts. See, all of them are getting saved here. That's the nice thing about MLflow. And this episode was more on the MLflow artifacts, and in the next video we are going to learn about how we can do a train sweep in the MLflow. You can see all of the matrices that are logged here, and yeah, that's pretty much for the first video. I hope that you were able to learn the basics. Thank you. Welcome back. Episode 2. So now we are going to use same dataset with better workflow. So the idea of this video is we want to do less and we are going to log more with the help of auto logging and evaluation. We will add in the last episode you have seen we have done lot of manual auto logging. This time we are going to use we are going to run multiple random forest model training, each with their own config and with their own full pipeline, and we are going to actually track which part of dataset are being used for what model, and we are going to learn about MLflow evaluates. So here is the code. This time I have copied the some lines from here. This is some configuration that I have done so that we have switched the folders. Usually we don't do that, but I am trying to get the same reference to same artifacts and all. So let's start with the train sweep code. First thing first, let's also get the now for this we will change the experiment name as episode 2, and let's give it a name of autolog. Now let's read the dataset, and since we are going to use same pre-processing, so let's also take that code. And now let's enable auto logging from sklearn. So log input examples. Yes, we want to do log model, and let's make it silent. Let's prepare a small sweep of configs. So estimators, let's define one as 150, maximum depth as 10, so let's train different model with 300 and depth of 12, and let's define one with none depth. For now let's keep only 3. So now let's make a variable that holds the result. with MLflow dot start run. Let's give the run name RF sweep. Parent as parent run. Let's give the dataset train MLflow data from pandas. Return as Firetrain. Let's also first copy the train rest splitting. And after that, let's give the source give the name smartphone. Returned train, and then we can do MLflow log input. Dataset train, let's give the context as training. For now, let's print the error if any error occurs. Now let's iterate for each config. With MLflow dot start run and run name, let's define as random forest cf config number of estimators times config max depth comma nested is true. So these are the child run. Now let's build model from this. Random forest classifier, number of estimator is config number of estimators max depth config and we can go with random state as random state job as 1s1 class weight is balanced, so CLF will be pipeline steps. First step is prep, where we are going to preprocessors. After that is the random forest, just the same thing that we have done. It's just we are running multiple nested. So now fit and evaluate. Train, my train, now let's calculate the accuracy score. I predicted, and also let's get the F1. Same thing. So let's log the top line matrices manually, and so that we'll also know, because some matrices we wanted them to be always present. And let's F1. F1, and also let's MLflow set. We can set the tags this time. So let's give it the stage episode 2, model family, random forest. Let's give it one method tag purpose. This is hyperparameter sweep. Now let's get the automatic. Same thing that we did for training. Now we are going to use MLflow evaluate. We'll pass the classifier. After that we'll pass data. After that here we have to pass the data frame. And then targets. Model type. It is a classifier. And we can define an evaluator. Let's use the default one. Let me check if everything is fine. All right. And if there is any exception, and so we will also append the results. So let's get them. This is CFG. I think this is done. Now let's try to run it. So to train sweep. So it is creating model. Okay, let's see if we get the auto sweep. It was successful. With look, here it is showing the data, all of the information. Now this is the parent one. Here you will see the child one. So if you click on this plus icon, now you will see everything, the tags that we have defined, the training scores, the preparation pipeline, and criterias, transformation. All of the information are being auto captured from here. Model matrices and the artifacts, precision recall curve, everything for all of the runs is available. Evaluation dataset is also, training dataset information is also available. So that's how you do proper experiment tracking with parent and child nested runs. Yeah, thanks. How can we do the hyperparameter sweep? We had trained 3 different experiments with their different configurations. Now this is the time where we need to select the appropriate winner model that we are going to use in production or stage. So in this video we are going to learn how can we register a model, and then how can we promote the model to appropriate staging, production, and also how can we retrieve any model, meaning using their production stage alias we are going to get the model and do some inference from it. So if you have been watching this video for first time, this playlist has 2 more videos, make sure to watch them. So this time I have written the code because otherwise it will become a very big video. So if you remember from our train baseline, we are doing the same thing. We are just setting up everything, as you can see. Now this is the main function which is responsible for getting an experiment. So tracking URI will be same for all, and it is going to create a client using MLflow client. We have instantiated a client object and we are getting a specific experiment that we have done. So we will be retrieving this experiment that we have done, and we are trying to register a model from there. So once we get the experiment, then we are going to do a search. So from this experiment ID, get all of the F1 scores in the decrement order. So we wanted the best model, so we are getting this is a condition. I mean, we can get all experiment, but we are getting on basis of some conditions. So we have calculated the F1 manual score. On the basis of that, we are getting the runs. So let's collect the first run, because from them best F1 score will be the best model. So let's collect the best model. We need to in the best model you have info and you get the run ID, and using that run ID we will take the model name that we want. It's smartphone return RF, and we are going to register that model. So once this is done, we will get the MV model, and we will get the versions by dot version, and we can also then set the alias as best with that model version, because we will set from this experiment whatever model have the highest F1 score will get the alias of best. So upon running this script, we should see a model getting registered. So let me run it. So let's run this code. So here you can see we got the I have actually run this code one more time. So if you are when you will run, it will get created with version 1. Since I am running it second time, then we are getting the model as version 2. So if you go, you see the model has registered with version 2 and alias as best. Its input characteristic is present, like which are the signatures, which are the feature vector it needs, and the output that it generates from this model. And then you can go to the source run artifact. Everything is present over here. Its estimator, peer curve, and everything is present over here. So this is how you do the registration. So this is the first step. Now moving on to next step is the promotion. So in production scenario, you're not going to change your code. You will be referring to the production scheme like staging, or people also say it pre-prod. Then we go to prod environment. So we need a way so that we can pick the best model and then first promote it to stage, and next if it satisfy the criteria, then we can promote it to production. So first thing first, this function is just a helper so that we can reuse this same function to send this model to multiple stage, like staging, production, or archive. So from here again same rule, you set your tracking URI, MLflow client, and then you create a client. Now what we need to do, we will collect information from user. Like right now I'll give the user that which model version that you want to get. So because we want always the best model, to anytime we do any experimentation, from that experimentation we want the best model. So let's retrieve the best model, and we need its version. Otherwise we can also provide the version, that's also possible. Then in the MLflow client, there's method transition model version stage. You need to provide the model name, which is the same thing, and then the version, which version, and then you need to at what stage you want to promote. Right now the existing version usually get archived, so we don't want that. We want to keep that model as well. So once this is done, it is going to promote it to any desired elevation we want. So once that is done, then we are also going to set the alias for that model, and let's run this code. Now this is how At what stage? Let's first promote it to staging. So you see alias staging v2. Again, why v2? Because we are I had run this before from v1. It will elevate to v2 because now v2 version is the best one. So v2 has been moved to stage. If you go v2 version 2 and you see staging, it has been promoted to stage level. Now same thing, you just need to provide next thing. Let's test for the production. So let's move this to production. Promote model to production. So v2 has been moved to production. Let's see. Now it has the add production alias. Now whenever you are going to make any API, so there you want to ensure that you always refer the production model. So how can you ensure that you always load the production model in your API? So for this I have created this file which is going to load the production model and it is going to do some inference. So same thing, MLflow set the tracking URI, and from there we will use MLflow sklearn.load model because we have got our random forest model from sklearn. We are going to give the model URI, and this is just the helper function which is going to read some sample inputs from our data set, and then it is going to do the predictions, model.predict. So let's see. So let's see. Yeah, so it has loaded this model, smartphone returns, random forest, production, and this is the first 10 predictions. So 0 means it won't get returned, 1 means it will get returned. So this is what is expected, and this is how you do model management in MLflow. And you can see this model from this sweep, this model has got been getting promoted to you can see this model got promoted. Now in the next lesson, how we are going to learn about how can we validate and promote on basis of criteria. Like this is what is called champion challenger based schema, where we are going to create a condition, and on basis of that condition, let's say any F1 score or AUC score, we are going to do like next because next time when you are going to run the experiment, you again will get best model. So then you already have a prod model. You wanted to ensure that the best model beats the production model, then and only we are going to accept it as a production model. So in the next lesson we are going to learn how exactly we can achieve this, and thank you for watching this. So we have learned how can we promote, register a model to production, and we have also register a model smartphone return RF to prod. Now we are going to learn how can we enforce the equality gate before promoting any model. So compare a candidate run or model versus current production or staging using matrices or statistical check, then only promote the model. So if you remember in the last video, I have been providing the input like promote this to prod, promote this to stage, but not anymore. We are going to learn how can we ensure this decision are being made statistically. So for that, what I have created one more file, and this is called validate and promote.py. So we are going to again use our same data set. So this is the some configuration, and we have imported the matrix calculation of F1 score, ROC, and accuracy score, because we are going to do the calculation. And we have defined a helper function which takes the model, because we will be reusing that same function to do the prediction from best model or either staging or production model. And it takes the feature vector and the labels, and it is going to call the predict, so that we get the predictions. And we will also try to retrieve the probability, so that we can calculate the AOC scores, because it needs the probability. Once this is done, we are going to return the matrices. Now we are going to ask user who is going to run this program that what is your candidate aliases. Right now this is always going to be best. This is a one-time decision, or in future if you change it you can refer it. So best is what referring the best candidate from a run of sweep. So you remember we have trained multiple hyperparameter models and we got a best model from there, and then you refer your production, either production or stage, however you want, and the minimum F1. So you wanted, like, what is your criteria for promoting the best model when it perform minimum 10.10 bet F1 score better than the production model. And same with the minimum AUC, like this much AUC has to be there. So, and there is another, like, promote if better. This is just because in some time our feature vector changes, then we don't want we actually want to promote the model irrespective of the matrices. So those cases also tackle here. So if now you must have remembered, like, first thing first, we need to set the MLflow tracking URI. Let's read the dataset, and then let's get the candidate model, candidate alias, and base alias. So we are getting it from here. Baseline alias is the prod or stage. So this is always going to be the model which is in your that you want to replace. So it can be possible both stage and production have the same model. So from sklearn, let's load the candidate model. Let's get the evaluation, passing it to this function, and then we get the candidature aliases. Then let's do the baseline one from prod. Let's load it and let's get the baseline one. Now let's prepare the gates. Let's see if it is passed or not. Now if we have just written a conditional, you can make your own conditions. I have made the condition in such a way that if there is any F1 score and that F1 score is greater than our minimum, then mark is less than the minimum, then mark this as fail. Or if AUC, so these are the minimum checks that we made. Now if the F1 of the candidate model is less than the baseline model, then also we are not going to pass. So this code actually work as a gate that fails the promotion of best model to prod, because by default we are going to make it pass. If not passed, gate is failed, not promoting. And then if this is not the case, then this is how you do switching. So MLflow client, this you get the client, you get the alias of the candidature model, and then you just register that alias as production and you set the version. This is how you do the promotion. So this is how you do a statistical way of promoting any model. Now let's run this code and see if it works. Python validate episode 4, validate and promote. So let's pass the candidature alias. Let me get it from here. So we can pass, let's take the promoting model as best and then base alias. Let's try to replace the production model and let's run it with the default values. You can see we were able to pass the gate, so we have promoted the production model to version 2, which was already there, but gate still got passed. So this is how you do the model promotion. The promotion logic could vary depending upon the use cases, so you just need to figure out how you can retrieve the models and their matrices, how can you calculate them, and then you just build a gate. This is a fairly design problem. Here your design matters a lot, how you want to achieve this. You just need to know that the method of doing the promotions. In the next video we are going to learn about how can we do batch score in production, and we are going to continue this, because the goal of the next video is to use production model to score new data in batch, log their predictions or any artifact, and we are also going to run our lightweight drift detection against training distribution. So this is how a real world scenario where your model over times degrades its performance. So we need to ensure that we detect the drift. We are going to learn in the next video how we can achieve that. Thank you. Video we have learned how we can statistically promote the model. Now in this video we are going to learn about the drift detection in MLflow. Over a time we want to calculate how our model performance is getting degraded or not. So this is also very important in the MLflow lifecycle. We need to detect as early as possible if the model is getting drifted away. So we are going to take inspiration from our previous codes, and I have done the code explanation in the episode 1, so feel free to watch it, why these configurations are set. So once this is done, your configuration, set the MLflow tracking URI, and this time we are going to set new experiment, which is batch scoring. Right now we have only 2 experiment, and here we have done the model sweeping, simple model train, model promotion. Now let's collect some data which we will use to check for drift. Usually this is a new live data that you might have labeled, or in case of unsupervised learning, unlabeled data that you will take. For now I'm going to use the same data because we want to learn the method. Data can be anything. Now you need to enter into the with context. You need to provide your run name. MLflow will start the run. We are going to specify which model for which we want to do. We have been using the smartphone return random forest model. We had trained it, we have done experiment with it. Now let's collect that model. The next sklearn model loads that model, makes prediction on the X that we have collected, preferably the drift data, and then we are also going to collect the prediction probabilities. Once we get this, let's save the predictions as prediction data frame, all the predictions that we have got, and also the probability. and let's save the prediction in a CSV file, because this is a auditable artifact we are creating so that anyone can refer it later on. So let's save this and log this artifact in MLflow so that it can be visible in the UI itself. Now let's do a simple drift check. Let's select include all numerical data column, and let's do the collect some of the reference window. Let's mark some of the reference window as drift and leave other windows as usual. This is where we are calculating the mean of those columns, numerical columns. Then we are going to subtract it from the normal one, the drifted one, subtracting the normal one, and then we are doing the calculation, the feature, mean, current mean, delta mean, reference, standard, deviation. This report we are going to save it as the report.csv, and then we are logging the artifact. Now we can this is a quick drift flag. Any large relative mean shift, we are going to flag it. So we are simple logic is drift from df mean will check if multiplying by 0.2 reference standard is it standard deviation is about 20% about the mean. If this is true, that is mean we have been drifted away. Then we'll calculate the drift ratio, and then we are going to log that artifact. So this way you will be getting the information of whether our model is getting drifted away or not. So let's do this and let's run it. And for running this, let's Python drifts batch score. So it has created new experiment, batch scoring. Here all of the drift informations are present, all of the artifacts, drift reports, predictions are present. It happened really fast because the data was very low, and also this report can be audited with more webhooks enabled to also trigger the training so that you get new model experiment and then you redeploy new model. So from here it's a design choice. You just need to remember like how can you achieve this. Thank you. We have been working with model, how we can detect the drift, promote them to production. Now we are actually going to learn how we can build and from using MLflow how we can serve the model as an API. So to do that, it's fairly very simple, because all you need is you just need to know the path of the model, and then you can do the MLflow serving. Let me show you how you can do that. So if you remember, we have registered the model as smartphone return RF, and let's serve the production model. So this is how you can do that. Type MLflow serve -m, that is model, and then name of the model. So let's copy the name of the model, this model, and which version of it. Let's use production, and we can specify port on which we want to run this API, and for now let's use the same environment as the local one. MLflow model serve -m models -m model path alias we are going to use production, and let's use the local environment. So this should spin up a API server, and it says at this IP and port it is listening. So what MLflow does, it has loaded the model, and then after that it has initialized the API. It's running on 5001 port. Now let's do one thing. We have created a client code which is going to hit this endpoint /invocation. This is where we do the predictions, and what we'll do for now, we'll just going to read our dataset and get some records and make a post request to this endpoint and see if this API responds back with the 200 status code, or it returns any response. Let's see. We are in the folder. Let's run Python client. Yeah, so it returned the status 200. That means we were able to hit this API, and you can see the backend log. It got hit with the 200, and we got the response as the predictions. And see, we have sent the batched request here, so we were getting the response as well. So this is how you create an API from your MLflow production model, and this is just a simple client that invokes that API. Thank you. We have built our foundation of machine learning with the help of MLflow, and we have completed about 6 core concepts of MLflow. Now I am going to teach you an interesting way of writing MLflow code for generative AI applications. One of the most important thing in the field of AI engineering is the tracing, because you want your system to be maintainable, and you want to have control over every aspect of the processes. Here MLflow helps really to establish the tracing of any tool call or LLM invoke from any side, either the client or server side. On our channel you will find the Pydantic AI agentic tool. Sooner I am going to upload the LangGraph as well. For now, what we are going to do, how can we use MLflow to make sure that our tracing are being done. So first of all, let's make sure that your MLflow server is running. So let's spin it up and let's see. So this is how our experiments are looking like. We have registered promotion model, and now let's see how can we do the tracing. So let me create a folder. Okay, so let's do some setup. Let me copy some of the code from here. Now let's prepare a new experiment name. So let's give this name as let's name it tracing, and let's use Grok so that everyone can follow the tutorial for free. It should not cost $1 for learning. So let's also import Grok. Let's install. Make sure to install the Grok dependencies. So as soon as this is done, now first thing first, for MLflow we have to set the experiment. By now you must have learned it. Now let's do it from MLflow. Let's also import MLflow. So MLflow.setExperiment, and then we will set exp as the experiment. Now let's define a function where we will do the LLM invoking. So let's define a function. We'll do same thing. Let's define a main function, and then you need to add this line. From here you need to add, let's prepare before in usually any LLM call we prepare the client first. So before doing that, we will enable the auto logging for Grok. Auto log, same way we do it for machine learning, here we are also doing it. So now dot Grok, we have prepared our client, and now let's invoke this. So client dot chat dot completion dot create, and then model. For now let's use llama 3 8 billion. I think its contact window is 8192. We'll check it on the Grok website. And then let's go messages. The format for this is role and then content. So let's define role first. Let's make it user, and then we are going to define the content. And let's pass it a prompt. Let's ask this a question. Explain what is MLflow AI. Now, once we get the message, let's parse it. Going to the messages dot choices, get the first one, dot content, and let's also print it. See if it works or not. So let's first thing first, let's see, try to build if it works. Let's go to Grok. And I will create a new API key. I'm going to invalidate this API key once I'm done recording. So do not share your API keys. Let's create .env and let me paste this API key and let's see what does Grok wants from us. Let's look at the implementation and API key. This is the way they will be looking into the environment. So let's go there. So and now coming here, we'll need to also from .env. Okay, let's add it. .env load load.env and then load it. So this will set the API key and we should be able to run this code. So let's run episode 7. Episode 7 tracing. Yeah, so you can see we were able to make the call, and if you look at the MLflow logs, experiment with does not exist, creating the new experiment, which means now we should be able to see the traces in the UI. Yeah, there you go. Now let's go to traces and let's see the traces. So we were able to capture the model. What prompt was that? And it creates an ID and what response we got back. Create a timestamp object that it called and the usage, chat completion, prompt token completion, prompt time, queue time, total time. Yeah, so this is how, because we just made an simple invoke, we were able to retrieve this much information. And once we do more tool calling and all, then we will be able to see the tool calling as well here. So for now, let's only keep the invocation and try to retrieve now information from the MLflow, these information that we have logged. Let's see how can we get it. So once we are done, let's try to get them. Let's put that in a try catch. Usually it's good practice to make any invocation in a try catch. So let's retrieve the last trace ID and let's make MLflow get last, I think it is last active trace ID, because if I'm going to run this code, it is going to create new ID and then I want to capture that ID and then let's collect the traces. MLflow get traces we need to pass the trace ID, which is last trace ID. So let's print the total usage. And let's collect the trace dot info dot. Let's now only collect token usage. And let's print this total usage. And this is how we will be able to retrieve the tokens, except exception as E. In that case, we are going to print the exceptions. Let's see if we are able to retrieve the usage. All right, there you can see from our MLflow server, we were able to collect the token usage, output tokens, and all. So this is how the basics. This is the basics of MLflow tracing. I wanted to include that in this playlist because just wanted to ensure viewers that you can also do tracing and all with MLflow. We will go more deep and dive in the MLflow AI itself. We'll create a playlist and organize all of the content separately there. And we'll keep this playlist for machine learning, MLflow related, but with the hint that we can do traces as well. And with that, I conclude this playlist. And kudos to you because you have been looking for a true knowledge, not for an AI hype. And there are very few people who understand the importance of these lecture, but those who do, I hope that it helps. Thank you. Thank you very much for viewing this playlist.